Come back. Problem 6. A torus is generated by rotating the circle x squared plus y minus r squared equals r squared, little r squared, about the x-axis. So notice, what is this? This is a circle that represents the y coordinate of your center, okay? And that's a radius of your circle. So in other words, let's look at the picture. There you go. So that's your circle. Center is 0, capital R. Radius of a circle, of the circle, is little r. And you want to take this circle and rotate it about the x-axis, about the x-axis. Find the volume. So notice, you take that circle and rotate it about the x-axis, you will get what is called a torus, that is donut shaped. I hope you can imagine, when you rotate the circle around this line, you get a donut shaped solid. So you want to find the volume of this. So notice, I'm getting washers here, right? There is an outer circle and there is an inner circle. For each x going from negative r to positive r, negative r to positive r, I am getting a thickened concentric circles. So the thickness is delta x. So I'm going to take integration with respect to x. For each x from negative r to r, we have thickened concentric circles. Radius of the outer circle. Radius is, you start from the center, go all the way to the top. Now notice, that's a circle. That circle could have very well been here, shifted up r units. So the top hemisphere is given by y coordinate. That's the top hemisphere, square root r squared minus x squared, and shifted up by r units. So that's the top hemisphere shifted up from here to r units, okay? So I hope you understand where I get this, right? You take your circle centered at origin, shift it up r units, or you basically solve for y. R squared minus x squared, take its square root, add r. That's the y coordinate for the top hemisphere. If I take positive square root, I get the top hemisphere. If I take negative square root, I get the bottom hemisphere. So top square root is with positive square root. Inner radius is with the negative square root, because inner radius is given by the lower hemisphere. All right. So volume is negative r to r pi outer radius squared minus pi inner radius squared, integration with respect to x. Outer radius, inner radius, and because I'm using washer here, I'm using pi r squared minus pi r squared, okay? Now, all of this calls for a simplification. Notice pi is a common factor. I've pulled it out. Expand this. R squared plus 2r square root. R squared minus x squared plus square of this is r squared minus x minus square this. That again gets me r squared minus 2r, so on. When you simplify, things cancel. All that is left is this term and this term. So 4r square root r squared minus x squared. So I have pulled the 4r out and kept pi outside. Now let's look at this integral. What is this? This is just the top half of a circle. top half of a circle, integral negative r to r is nothing but area under the curve. This is what we learnt in first calculus course. Integral negative r to r, some function dx, is area under the curve. But the area under the curve here is the top half. Circle centered at origin, radius r. That is, this integral is half area of the circle, pi r squared, little r being the radius. So simplifying, I get 2 cancels this, 2 r squared, pi and a pi squared, cube units. So I hope this was clear. 2 capital R, little r power 2, and pi power 2. It's correct. So that completes our problem list for section 5.3. Next videos will continue with the newer topics. Until then, bye.